Hello, I will show you now how to use this Python model, which is used to fit extreme value distribution using L moments. This is something you have to do, you must do for designing any hydraulic structure. So this is in fact applied hydrology, right? And in applied hydrology, when you want to design anything, then you need to feed your your historical data with some distribution, which is usually extreme value distribution, because you have to do it for different return periods, so you need a lot of data. And I'm not going to explain the theory because this is oriented to people who is interested in hydrology, hydraulics, and I think the theory behind you can read it, and you already have the basis probably. So I will just go to the model, which is a very straightforward model, but it is very accurate, and it will help you fit any extreme value distribution, the most applied ones, the most common ones, to your historical data. So you apply it like frequently, and most usually you apply it to precipitation, to rainfall, because that's the data you usually have, and the most historical one. But sometimes you have also discharge flow. You can apply it already this to flow as well if you have enough flow data. So that's another approach. As I said before, I won't go into the theory too much, right? That's something that you can read and you can learn. But I will say that the moments, and I think for now, is the best and the most accurate statistical method to do this, to fit distribution. And if you want to design any hydraulic structure, then you have to fit a distribution, and then you have to create some IDF curves, and then design storm, and then do a hydrograph or anything. But it's very important, and this is the first step, in fact, in design, that you need to do this, right? Because you have data, then you have to use it in any way to apply it in any model. So there are some models as well, but this one is very easy because you don't need basically anything than a Google account. And I will show you now what else. I will explain some theory, but just the basic one. Okay, this is a Python model, in fact, which is called L moments, IPYNV, which is an extension for Python. You can also open it, this one, in Jupyter if you know already some Python, but I will use Colab, so you can use it just with internet. You don't need any software, you just need a Google account, which everyone has. Just put Colab there, and then use Colab, right? So you have just to open Colab and upload this model, right? I have it in the desktop. In fact, is this one. I have the identical one for flow. It is exactly the same, but the units are different. But I will work with this one because precipitation is usually the main variable, the main parameter as well, that we have the hydrology, right? Our input is usually precipitation. It's always precipitation, basically. So again, this is the model. The only thing you need besides a Google account is your data, and the data is just precipitation, right? Which is usually which should be extreme value, and so usually we apply this for, which is called, and let me show here. This is a data. This is annual maximum daily rainfall, so which is the maximum daily rainfall in a year, right? So you can, there are also some other methods, partial duration, for example. Anyway, you can apply it anyway to other methods. You can apply, because this is just a statistical method, probably the most accurate one for now. but you can apply it. But I will apply it to this data, which is annual maximum daily rainfall. So annual maxima is also called. It's very easy. You should have the data in Excel format, in any format you have, but you only need to put the data. You don't need the year, anything. You don't need to put it in a sorted way from lowest to highest. Nothing. You just put it in however you have it. If you have it from lowest to highest, or you have it chronologically like here, it doesn't matter. You just need a txt file. So for that you only need a notepad and just copy and paste. So you just need this format for the data. This format, it doesn't matter, because in extreme value distribution you only need you only need the data, right? You only need the values. It doesn't matter when it specifically happened. You can also analyze that for climate change or other kind of analysis, but you really need the data, in fact. And then it has to be sorted, but you don't need to sort it here because the model will already do it. So here this is a rainfall station called San Calixto. So I will save it with that name. Let me save it also in the desktop with San Calixto, like this. Okay. And that's it. It's recommendable not to put any space. Okay. So that's it. Its name San Calixto. And it's here. Okay, just the same. Yeah, we have the data here. So if you want some insight, a really strong insight, you should read the Applied Hydrology from Bente Chao. You can find it in Google. I cannot provide it because it's a book, right? But and it's not my book, it's Bente Chao's, and I think it's great. It's an old one, but it's probably still one of the best hydrology books. So if you read this, you will see that in chapter 11 you have all hydrologic statistics that you need, and chapter 12. So let me go to chapter 12. Then you will have some frequency analysis. Extreme value analysis is also called extreme frequency analysis. Okay, so here you can read about some extreme value, how it is applied. So you will see the same basically as the model. However, here you will see that you have to fit the distribution. So here they use the method of maximum likelihoods and also the method of moments, which are the first ones that were used. But L moments, the linear moments, were presented by Hosking. So I will leave also the link to this paper. I cannot provide the paper because it's not mine, right? But I will also leave in the model. In the model at the end, you can just click in the links and you will go to it will take you to the paper. Okay, so you have university account and you can read it, and also if you Google it, you can also find it. Okay, so yeah, this is the paper if you want to read all of the details about the L moments, but basically you have the formulas here. Okay, so, and I also provide here at the end of the model this couple of files. You can just click and you will download it. Okay, and it's very easy. Just download and that's it. Anyway, and then you will have it. It also happens with this, which these two files are also, but they summarize everything. So these are the L moments parameters. So these are the L moments. This is, I will show you with the model how it works. But these are the variables that we use in the model. And Rainbow, this is small software made with the FAO made, which is also frequency analysis, and you can read some basic theory here, but the most important here is taking this you can call it empirical data. So this is just the way to put your data, to rank your data in some way. So I will show you now so you will understand, but you have this theory here. The book of applied hydrology I cannot provide, but you can find it in Google, right? So you can read about these methods. It doesn't have L moments because L moments were developed after this, and but it's an improvement of these two methods. Of course, the basis is the method of moments, which has always 2 parameters, but L moments has 3 parameters, which are like shape, location, and one more, shape, and yeah, we have them here. K, A, and U. Okay. And I also have an Excel that yeah, so it's shape, location, and scale. Sorry, I will show you this at the end as well. Anyway, this is the model, so I will now show you how to use it. Okay, it's basically just putting the play button here, is running the model, because it's just there, and you can just use it. However, here in the second step, in the frequency analysis, you have to change the name. If you have another name here, just this name, you have to keep the quotation marks, and you have to keep the extension, the txt file, and just change the name. But before that, you have to upload here. So here you can do 2 things. You can drag here, so that's one way. Okay, you can delete it. I will show you just the other way, just uploading like this. Any of those 2 works. So that's, but this name, oh sorry, this is not a, sorry, I have to delete it now. You have to upload the file, which is not here, should be here, right? It's here, San Calixto. Sorry, San Calixto is the file. So now you have it here, San Calixto. Okay, you can close it. It will be there because you uploaded it, so it will be there. You don't need it anymore there. So once you upload it, then you can run it. If you don't do this, it won't run. So just do it. Put the correct name. Be sure that you have exactly the same name, of course, without the quotation marks here. If you are using Jupyter, you have to put the whole path, and you should put an R here. That's the difference. You put an R and you put the whole path, and that's the only thing, and you don't have to upload anything. That's for Jupyter, but that's something else. This is just Colab. Once you run it, you can run it as many times as you want. You will have the data here. So this is chronologically, so the same way I have it here, and this is the rank number. So you will see that the highest are you will have 99 values, because you have 99 years from 1917 to 2019, but I think 99, 91, and 92, 93, 94 are not, there were not records for those years. So yeah, that's why you have 99 years, which is a lot. And yes, so this is just the rank number. Okay, so you use it for example to sort your data. You use the rank number and the total of numbers, which is 99 in our case. So that's the way you do it here, and then you play it here, and here you will have this, it's already ranked. That's what I told you. When you have your data, it doesn't matter how you have it, it will rank it automatically. So it will go from the lowest to the highest. This value is number 1, so it's the lowest from the whole historical data. Yeah, it's number 8 because it must be the 8th year. So yeah, this is the 8th year. It doesn't matter however, it should be ranked this way. And then we have the beta here, which is the first set of parameters for the method. Just how you do it. And now I will run this the next step. Sorry, this one. Just play it. This is just to calculate all of these parameters, L and T, which are the L moments as them, right? So you have this, and now just click this way and you will fit the distributions. Okay. Yeah, I don't want to go to the theory too much, but these are the distributions that you can see. Hoskins, the most usual ones are Pareto, logistic, extreme value. So these are, and Gamble as well. So these are the ones I'm using, but I am also using the Pearson 3, because Pearson 3 is very used. So yeah, you can see it as well here. They use it a lot in, yeah, if you go to apply hydrology, you will see Pearson 3, right? And if you are in the United States and any place of Latin America, you will see that it is also used a lot. So those are the ones for this, which are the most applied ones. You shouldn't use other one, okay? And then sorry, again, in this I wanted to show you that you have the return period here, and this is the probability of exceedance, right? F. All of that you can read it here in the rainbow as well. What's the meaning of that? Okay. However, I just want to show you that I am using the Green-Gotten formula here. This is the one for the data, right? So I am sorting the data using the Green-Gotten formula, which is one of the most accurate one. It doesn't matter too much. For example, if you have 99 values like me now, if you use this California, which is very easy one, then you will know that the highest value, which in this case is for example is this one, almost 60, is 59.9. this will correspond to a, it's easy, right, to a, this will be 99 over 99, so it will correspond to a 100 return period. However, in this case it corresponds to a 177, and it has more sense because this is very high compared to other ones. This is an event that occurred in 2002 in La Paz, in Bolivia, and it was a very strong one, and historically is the worst event, so it must be like this. But this is only empirical, you know, this is the return period for your data. You are not fitting anything yet, right? Anyway, so you have it there. If you want to use another, just you can check here, just use different equation and just change it here, but you shouldn't do it. I don't recommend it anyway. Okay, so you already played this. You can play it anyway. If you don't remember you played it before, you can play it again, it doesn't matter. Then you run this, you just run all of the models, and here you are already fitting the data. So you are creating different return periods, the most usual ones, and you are fitting the most usual distributions, the most applied distributions, which are the general extreme value, the general logistic, the general Pareto, the Gamble, and Pearson 3. Okay, so you will see a tendency. For example, the general logistic is generally higher when the return period is higher. So for higher return period, you will have higher values for GLO, for example, and Pareto will decrease. But for the lower values, Pareto will be higher than the other ones. Okay, you will see that tendency. That's a tendency for that happens when you compare all of these distributions. Okay, and here you just plot it. You just plot it and you have it here. You will see this is the Pareto one because it was the highest one at the beginning, and then, but generally the annual maxima method, the annual maxima, when you have annual maxima like us data, it won't follow this trend, the general Pareto, but I put it anyway, because if you use another method, like I won't explain it, but there are some other methods when you put a threshold, the partial duration method, then probably it can fit our general Pareto. So we can see here that this data fits probably a GEV, a Gamble, or a Pearson 3 distribution. Okay, so it ends here. Basically, you can change if you don't like these colors. You can change, for example, yellow. If you don't like yellow, you can put cyan, for example, and you run it again. Then you have cyan here, right? So it doesn't matter. This is only for changing the colors. Yeah, I will keep yellow. Okay, so K is for black because B is for blue. At the end, you can run this and you will have your values for this, for the most important or more useful return periods: 2, 5, 10, 20, 25, 40, 50. So this is a summary of the return period and the rainfall corresponding to this distribution, right? And with this you will export it to Excel. Okay, so if you want it in Excel, then you play this and you will have it here after that. Okay, and here you just download, and then the output is there, and you will see the output is basically this is the return period. This is the same, but you will have it in Excel now. So for all the return periods that we can have, yeah, okay, the most important ones are there. It's easy because they don't have decimals, right? For 8, for 10. Okay, so you can export it in Excel as well, and that would be it. And then you have what already I showed you before. If you want to change everything, you can do it, right? I don't have some more data, but you can run everything again as many times as you want. You can delete this file, for example, keep this, and now if you want to run it again, just change and change something. For example, if you don't have one of the, let's keep this file because I don't have another file, but if you want, if for example there is no this value, just delete it. If you have another set of data, just change the name of the file. I will change it, so just to show you that you can do it very easily. Sorry, just change the name. So F2, put it rainfall. Okay, so this is the name of the file. Now I will just change this. I only need to, I will delete this, upload the rainfall file. Okay, and if you want to run it all at once, just come here and put run all, and it will run everything. You just need to, this check will tell you that it's already run. So see, yeah, it looks similar, but you have less values, and you can see that here you have 98 now. Very easy, but yeah, you can see similar things because it's only one value, but it changed, right? So that's it. So how can you get this? I will show you now. But besides this, I am also providing the same thing, but with flow, which is called all the same, but flow into parentheses. So you have exactly the same, but it's very easy because I only changed the units. In this case, for example, I use a file this is the name of the file. I won't run it because I don't have it in this computer, but this is a file in flow recorded in the UK where I live now. Okay, you just have to put this in sorry, like this. Oh, sorry. Yeah, that's the only thing, right? And then I will correct that, but you only need to change this name, just that, and then everything is already there. If you want to change the units anyway, it's just here. You just change the units here. Reduce variant is this, and then return period is here in years. That's the name of the access, right? So you will get it as well. Of course, in flow we usually have less values. Okay, so yeah, here for example you have 41 values. Of course these are higher because this is flow data, cubic meter per seconds, right? And in England you will see generally the flow data fits a general logistic distribution. So yeah, you will see that here as well, but you can use it with your data anyway. Okay, you will also get this one. What you won't get directly here is this. This is the I will leave the link to the video of explaining this is the file. For example, here the first step, as I said before, is fitting data. When you feed the distributions, then you can do the IDF curves, and then you can create a design storm. And if you have the data from the catchment, so area and the curve number, this uses the SCS curve number method. So I will explain this in a video in which the link I will leave in the description. So then you will have a unit hydrograph, for example, and then you will have the hydrograph, right? So this is also part of my set of videos and models, but this one I will explain it in another video. And now we want to get this one. It's easy to do it. In fact, I will leave a link below where will take you to my camera, right? So I will let you as well some. I will also I also have the Excel for this, and I will also put the link below in the description. So it's exactly the same as we did, but in Excel. It's a little more, it's not as straightforward as the one we had, but probably most people can understand it in Excel as well. So I have it for Excel, and I will make another video and will show you this and leave the link in the description. But I will leave a link also in the description to purchase this, and you will go, in fact it will take you here. I will put 3 links. One, it only costs $4, so just buy it here and just buy it. Sorry, here I have more that from others, but it's just this. You will have to put some VAT, and that's it. I will also leave if you want the Excel, I will leave it, and then I will leave a file where you can get both of them for just $6. The Excel one is $3, so you will save $1 in fact if you want to get both of them at once. If you buy this, then for example, if you buy them, then you will get the Excel file and the Python file at once. You won't need this, right? It's just this. And yeah, I think that's it. Thank you very much.